Okay, so we're going to be going into type 1 and type 2 errors. But we want to start with a review of p-value and alpha because having a good understanding of that is extremely important for errors because essentially that's where our errors come from is those comparisons. So p-value, a p-value first off is a conditional probability. That means it has a given statement in it or it's implied. So basically, a p-value is the probability of getting a test statistic as extreme or more extreme than the one we calculated. So it's calculated, given that the null hypothesis is true. And so here's what we're saying. Given that the null is true, how likely is it that we will get a test statistic that's extreme? And to put that in perspective, when we run a test, we're never going to get 0%. Now, it may be really close to zero, but we're going to get some probability. So when we run our test statistic, we get a probability. We sit there and go, well, the probability of this happening is 4% or 20% or 1% or 0.001%. At some point, yes, it says given the null is true, there's a less than 1% chance. And at some point we go, you know what? I don't believe the initial claim. So whatever the initial claim was, we got such a small probability of getting a sample that would occur by random chance alone that we're going to reject the null. Okay, so putting the p-value in context, this is extremely important. It's going to be found here. It's also going to be found on the recipe card that we will get to in one of the later videos. So there is whatever our p-value is, 2% chance that we get a test statistic this extreme in favor of, and then we're going to restate our alternative when in fact the null is true. This is important because this right here provides the template of how we do p-values. Okay, please note the p-value is not the probability that the null hypothesis is true. It's given that the null is true, how likely are we to get something this extreme? And like I said, if we get a small enough probability, we go, you know what? That's such a small probability that this happened. I don't accept the null as being true. So how to think about alpha levels. An alpha level, first off, it's the area in the tail. And basically, we predetermine it. So with the p-value, it's kind of important to note this, with a p-value, we actually calculate that from our test data. Our alpha level is the area of the tail, and we actually choose that. And we say, you know what? If we set an alpha level at a certain level, we're going, you know what? I don't mind being wrong a certain amount. Now we're making comparison of our p-value to our alpha. And we arbitrarily choose the alpha. So alpha is predetermined, we choose it. So it's predetermined and we choose it, and we choose it based on what we think is appropriate for the given situation. For AP statistics in general, if they don't tell us, we use 5%. And I always say that we choose 5% is because really we don't mind being wrong too much if we're 5% of the time. And why I say that is if we make a 95 on the test, that means we were right 95% of the time and we're wrong 5% of the time, and we're generally okay with that. Some cases we need a much smaller percentage. In other cases, a larger alpha level may be set. But regardless, alpha is predetermined, and then we actually calculate the p-value from the test data. And remember, if the p-value falls below that alpha that we predetermined, if it falls below, we reject the null. All right, so that's nothing new because that's what we've been doing with hypothesis tests. All right. If the p-value is large and does not fall below, then we don't have enough evidence to reject the null. All right, so if the p-value is large and does not fall, the data have failed to provide sufficient evidence to reject the null. We never accept the null. We either reject or we fail to eject. All right. So, as I mentioned earlier, alpha is the area of the tail, and it's really a risk of error that we are willing to take in rejecting the null. The risk of error, and so we probably should add the word error there, that we are willing to take in rejecting the null, or in rejecting not just a null, but specifically a true null. Please understand, not all nulls are true. And an alpha level of 0.05 means we expect and accept the idea of incorrectly rejecting the null hypothesis 5% of the time. In other words, 95% of the time we will reject a false null, and 5% of the time we will reject a true null. And that's if we did it over and over and over again for test after test after test. In other words, that's the infinite idea. So if we performed this test an infinite number of times, 5% of the time we would reject true nulls, and 95% of the time we would reject false nulls. Now, the error that arises that we're talking a risk of is due to natural variation. All right, this is really key, that it's due to natural variation that comes from sampling variation. And another word for sampling variation is sampling error. Excuse me with that. And sampling error does not arise because someone made a mistake in taking a sample. We discussed this earlier in the year. Sampling error it represents a natural variation that occurs due to randomness, and because every single sample is different, we have variation, and that sometimes we refer to, instead of sampling variation, we refer to it as sampling error. And due to that, we're going to have a risk of rejecting when we shouldn't, and that risk is going to be our alpha level that we just preset. Please remember, you can set different alpha levels, but every single test will only give one p-value, and that p-value, once again, comes from the data that you collected. So I know we like to be right, so why wouldn't we choose a small alpha to minimize the chance of mistakenly rejecting a true null? And I think that's a great question. Why wouldn't we? Well, because it becomes very difficult to reject a false null if we choose small alpha. So we should say it becomes very difficult to correctly reject a false null if we choose a really small alpha. So that's why there's a balancing act between, do we choose a really small alpha or a medium-sized alpha, or where do we choose an alpha at? And that selecting alpha is a balancing act between the two types of error that we're going to talk about in our next video. Rejecting a true null, which is type 1, and rejecting a false null, failing to reject a false null, which is type 2. And I'm going to real quickly say this, just because you reject doesn't mean you committed a type 1, but that's the only type of error you might have committed. Failing to reject doesn't mean you committed a type 2, but that is the only type of error that you could have committed. All right. So our two types of error are type 1, which is when you rejected a true null, and the other type of error is a type 2, which is failing to reject a false null. And we will go into that in more detail in the next video.